We will be looking at solving systems of nonlinear equations using two methods. We want to be able to solve them using substitution, and we also want to be able to solve them using elimination. For the types of examples that we will be studying, we will see that substitution works most of the time, and that there are specific cases where we want to use elimination. So first, getting started, what is a system of nonlinear equations? A system of nonlinear equations is a system where we have two equations and at least one of them is not linear. So we have seen so far that the equation of a line can take many different forms, and here are three examples of them. So one of our equations will be at least one of these forms, will be a line, and the other equation will not be linear. I will point out that the defining characteristic of a linear equation is that in a linear equation, both x and y have an exponent of 1 on them. So in all of these equations, the exponent that shows up on y and x is 1. It could be 0 if we have a vertical or a horizontal line, but the exponent on x and y will not be higher than 1 in a linear equation. So we're going to talk about three different types of nonlinear systems. The first one we're going to talk about is a line and a parabola. Then we're going to talk about a line and a circle. And then we are going to talk about an ellipse and a circle. And we'll get into detail on how to solve each of those three types of systems. So getting started, we have the intersection of a line and a parabola. So I have three graphs here showing us the three different possibilities that we could run into. In the first case, we could have a parabola and a line that never intersect each other at all. So there would be no solution of the system. Because what we're looking for is the point where those two graphs touch each other. So it's possible they don't touch each other at all. It's also possible that the line and the parabola only touch each other at one point. So whatever that point is, x comma y, that point would be our solution. It's also possible that the line and the parabola touch each other at two separate points. So we could have one solution at x1, y1, and we could have a second solution at a different point, x2, y2. So we have steps here, steps 1 through 4, outlining how we solve a system for a line and a parabola. And we'll go through these steps in example 1. So in example 1, we have a system of equations. Do note that the first equation is linear, and I know that it's linear because both x and y show up with exponents of 1 on them. The second equation is not linear, it is quadratic. And I know that it's quadratic because x shows up with an exponent of 2. So that is not a line. That second graph is a parabola. The graph of a quadratic is a parabola. So let's follow these steps to solve this system. So step 1 tells us to solve the linear equation for one of the variables. Well, this is the linear equation. The linear equation is x minus y is equal to -1. I'm going to take that equation and I'm going to solve for one of the variables. I can either solve for x or I can solve for y. I'm going to choose to solve for y. So I'm going to take this equation, I'm going to subtract x from both sides. And then I'm going to multiply both sides by -1 or divide both sides by -1 to get rid of the minus sign that's in front of that y, which leaves me with y is equal to a +1 plus x. So in step 1, what we did is we solved for y, and we did it in the linear equation, so the equation that's underlined in blue. So we've completed step 1. Step 2 asks us to substitute the expression that we got from step 1 into the parabola equation. So step 1 told us that y is equal to 1 plus x. So I'm going to take the parabola equation, which is y is equal to x squared plus 1, and I'm going to replace this y with 1 plus x, with what we solved for in step 1. So we now have 1 plus x is equal to x squared plus 1. Now we're on to step 3. Step 3 asks us to solve for the remaining variable. So now I'm going to take this equation and we're going to solve for x. The equation that we have now is a quadratic equation, and we solve quadratic equations by getting 0 on one side. So I'm going to subtract 1 and I'm going to subtract x. So that leaves me with 0 on the left side of the equation. There's only one x squared term on the right side, so we only have x squared. We have a minus x, and these ones cancel each other out. We can solve this equation by factoring. I'm going to factor out an x, and then I'm going to set both of those factors equal to 0. So I get x equals 0 from this first factor, and I get x minus 1 is equal to 0. Then I'll add 1 to both sides to see x is equal to 1. So we got two possible values for x here. We got the value of 0 and we got the value of 1. So now we are on to step 4. I'm going to pause here. We're actually not on step 4. We're still in step 3, because remember what we're looking for is we found 2x values. So it looks like we might be in this solution, in this case, where we have found these two x values for the points. What we're still missing, what we don't have, is what the y values would be. So let's talk about what those y values would be. So we have two cases. We have a case for x equals 0, and we also have a case for x is equal to 1. And in both of those cases, you want to know, well, what is y? Well, we have this equation here. It says y is equal to 1 plus x. So if y is equal to 1 plus x, then when x is 0, y would be 1 plus 0, which is 1. And when x is 1, y would be 1 plus 1, which is 2. So we have two possible solutions of the ordered pairs 0, 1, and 1, 2. And step 4 requires that we check these solutions, that we check them. So what I'm going to do is I'm going to take this solution of 0, 1, this first possible answer that we got here, and we're going to plug it into both of these equations and see if it's true. So I'm going to replace the x's with 0 and the y's with 1. So in the equation x minus y is equal to negative 1, I'll replace x with 0 and y with 1, and that is true. In the equation y is equal to x squared plus 1, I'll replace x with 0 and y with 1, and that is also true. So 0, 1 does work, and it is a solution. Now let's check the solution 1, 2. We're again checking them in both of these equations here. So I'm going to see, are those equations true when x is 1 and when y is 2? So when x is 1, in the equation x minus y is equal to negative 1, I would have 1 minus 2, which does equal negative 1. That's true. Let's check the equation y is equal to x squared plus 1. So I'm plugging in 2 for y, 1 for x. 2 is equal to 1 squared plus 1, so that's also true. And so 1, 2 is another solution. So we did find two answers, the points 1, 2, and the point 0, 1 for the solutions to this system of nonlinear equations in example 1. So I will be checking to see all of this algebra on your paper to see that we are actually going through this substitution process to get these two possible points of solutions, and then checking them in step 4. But I want to show you how we could confirm our answer with Desmos. So in Desmos, I'm going to type in the first equation of x minus y is equal to negative 1. That's the line. We can see the graph of the line there. And then I'm also going to type in the second equation, which is y is equal to x squared plus 1. That's the parabola. We can see the graph of the parabola pop up in Desmos. And notice that Desmos does kind of highlight these 2 points. 1, 2, and 0, 1, which are exactly the 2 points that we got as our solution right here when we solve that in that black box.